Hi guys, we are back. This is Parker. He wanted to say hi, so I thought I would.
You've already introduced me.
Well, not to my geometry class. I didn't introduce you.
Oh yeah.
So you're gonna say hi.
Hi.
Hi. So we're gonna be working with ratios of similarity today, a little bit like we did before. This one's pretty short because we are just really looking at, now that we know how to enlarge or reduce the volume or the surface area, we are going to look at just the ratios and the fractions that work with it. So this will go pretty quick. So I'm going to close off this window, and we'll see you real soon.
You guys can do it.
He says you can do it. All right. So on our
First grade.
On our area similarity theorem, we've kind of already talked about this, so I've got it highlighted here just to kind of make sure you know that whatever the ratio is, if the solids are similar, their areas is equal to the square of their side lengths. So if their side was a over b, then their area would be a squared over b squared. And then the same thing here, if the solids are similar, then their volumes will be equal to the cube of their side lengths. So if their sides are a over b, then it's a to the third over b to the third. So I have a really quick example here. If the side lengths were 8 and 12 on a shape, we would reduce this fraction. So the similarity ratio, or the zoom factor, would be, let's see, we would reduce, this would become, we could divide by 4, so that would be 2 over 3. So there would be their similarity ratio. And then if that's reduced, then all of the rest of these would be reduced as well. So our area ratio, we would just take this and square it, 2 squared and 3 squared. So this would be 4/9. And then if we wanted to do the volume, we would take that same similarity ratio side and we would cube it. So 2 to the third and 3 to the third. So this would make this 8 over 27, and that would be our volume ratio. And you could have this upside down as well too. It could be 27 over 8. It's the same thing. It doesn't really necessarily depend on one direction or another. Okay, so then here I've got a couple for each pair of similar figures. Find the similarity ratio, the surface area. So basically what we just did. All we have to do here is look for matching parts. So here we have, like, you could look at the height. You could say we have 6 and 27, or you could take the base. We have 10 and 45, and you're just going to compare them. So you could do left to the right, smallest to the biggest, or you could go the other way around. It doesn't really matter. I'm going to take the 10 and the 45 because I know when I try to reduce them to their similarity ratio, I could divide by 5, which would make this just 2/9. And so then our surface area ratio, we would just square it. So 2 squared and 9 squared. So we would end up with 4 over 81. And then for our volume ratio, we're going to take that same thing and we're just going to raise it to the third power. So this is real quick. This would be 8 over 729. With the second one, and I mean, obviously we've done this a couple of times now. The only reason I want to look at this one is just that it's easy to make a mistake when you're comparing. So notice here, this 24, that's the diameter of our figure. And when we are looking over towards the other shape, the 27 that they gave us, yes, it's bigger, but this is only the radius. So these are not comparable values. We can't put them into the side length ratio because they're not the same side. We could take half the diameter, we could take the 12 and work with our 27, or we could just take the heights for both of these, the 16 and the 36, and we could compare them that way. And so then looking to reduce 16 and 36, they both have a 4, and so that would give us 4/9 for our ratio. And then our surface area, then we'll just square it. So this would be 16 and 81. And then for volume, we would take it and raise it to the third power. So 4 to the third power and 9 to the third power. So 4 to the third power would be 64, and 9 to the third power again would be 729. Parker, please don't do that. Okay. So then the last two little examples I have here, like I said, going real quick, this is now putting it into some application. If the similarity ratio is 2/3 and the volume of this we're assuming here is going to be the smaller figure, because it says find the volume of the larger figure. So what I'm going to do here is I'm going to take my similarity ratio and I'm going to make it so that the larger number is on top. So that's going to be 3/2. And what I want to do is I want to, if I'm trying to find volume, I need to raise this to the third power. So 3 to the third over 2 to the third. So that's going to be 27 over 8. And that's our volume ratio. And so then what I need to do is just take, if I want to find a larger figure, since the larger number's on top, I'm just going to multiply by the volume that I already have, 1024. And so then that is going to give me, let me do this quick calculation, 27 divided by 8, which would be about 3.375 times 1024. And so our larger volume, and our answer should be bigger because we're finding the larger volume, is 3,456 yards cubed. Okay, not too bad. So then for the last one here, it says the two solids are similar. The larger figure has a volume of 1,728 cubic inches and a height of 15 inches. And then the smaller figure has a volume of 512 cubic inches. So we want to know what is the ratio of their sides, and then also what is the height of the smaller figure. So first thing we'd have to look at or compare is what's the ratio of their volumes. Now, since I'm going to be looking for the smaller figure, I'm going to put the smaller number on top. So 512 over 1728. And I'm going to reduce that. So 1728. If I just divide it, I get this really awful decimal. It's 0.29629. That's not really going to work out so well. So what I can do instead is I'm going to push on my calculator, I'm going to push the math button, and it's going to make a fraction for me. And I'm going to get 8 over 27, which is actually really handy because, hey, that's the same values we just had before. So what we want to figure out, so this is the volume ratio, we need to get the side ratio. So we need to basically go from our volume ratio back to our similarity ratio. So we need to undo the cube. Or we basically have to ask ourselves, what to the third power makes 8 and what to the third power makes 27? Well, what's really handy about these numbers is that they are the same ones we've already used. So we know that 2 to the third power makes 8 and 3 to the third power makes 27. So our ratio that we need is 2/3. And then finally, how would we find the height of the smaller figure? We would take the height that we have, and since we are trying to make it smaller, we can multiply by our fraction that is less than 1. So if the fraction is less than 1, that's how we get our ratio, how we shrink our values. If the fraction was more than 1, then we would enlarge our values. So it all has to do with oneness. And that's it. I mean, that's basically all you're going to be working on today. Some of it's going to have a lot of review, but most of it's just going to be, how do you get your ratios? So can you find the surface area ratio? Can you find the volume ratio? Could you undo it? Could you go backwards? That kind of thing. So there's just a couple of problems where you're going to be doing like you've been already doing, kind of like this, where we are just sort of using our ratios to find a new value. Okay, so good luck.